In this video, we will start solving the Unit 2 review packet, which is about linear functions. I'll begin with the first question, which says to solve this system of equations by graphing. So we have to graph these lines one at a time to find our solution. If we start with the top line, I can see y equals 3x minus 8 is in slope-intercept form. Y equals mx plus b form. So looking at this form, I can see the y-intercept, b, is the number -8. So I'll start drawing it down here at -8 on my y-axis. And then I can see my slope is the number 3. The number 3 has an invisible denominator of 1, which means that this slope is a rise of 3 and a run of 1. So I have to go up 3 and over 1 to find my next point. I can continue this a couple of times if I want to, so I can get a nice straight line. There we go. And that's going to make the line for this top equation. So let's draw that line in here. Okay, there we go. Now for the bottom equation, it's also in slope-intercept form. The intercept b is the number -8, again, right there. And the slope this time is the invisible coefficient of x, which is the number 1, which is also being divided by an invisible 1. So up 1 over 1. So these points here show a slope of up 1 over 1. A little messy, but there we go. So if I connect these points, up 1 over 1, here we go. And this direction as well. There we are. So we have our two equations graphed. The solution, I'm going to skip ahead a little bit, is where these 2 lines intersect, which is right here at their y-intercept, the number -8 on the y-axis. So that ordered pair would be 0 for x, -8 for y. Now to classify this system of equations, these two lines are possible to be solved. They do intersect in at least one spot, which makes them consistent. So one graph consists of the other graph at least one point. But they go in different directions. They're not completely overlapping. So they don't depend on each other. They are independent. So they go in different directions. So they have different slopes. Let's go ahead and identify the key features of these functions. All right, so we have to identify the key features of the function 3x minus 8, which is the one we graphed in red. The easiest key feature to see is the y-intercept, which is that solution, that 0, -8. And we can see the slope really easily as well. That was the number 3 that we saw in our equation right there. But to find the x-intercept, I'm going to have to do a little calculating because the x-intercept is happening here on my graph between the x values of 2 and 3. And I can't guess and just say that I think it's near 2.5 or something like that. I have to be specific and I have to find it using math. The thing I do know is that this x value is happening on the x-axis, and the x-axis right here has a y value of 0. That I know for sure. So if I take my equation, y equals 3x minus 8, and I take the y value I know it has to have, 0, and plug that in, I'm going to be able to solve for that exact x value. All I have to do is solve for x in this equation. So I can add 8 to both sides and see that 3x is 8, and then I can divide by 3. This does give me a fraction. X is the number 8/3, but that's, if I type that in the calculator, I think it's 8 divided by 3 is 2.66 or something like that. So it's somewhere between 2 and 3, which confirms what I see on the graph. So that's the x value I'm looking for my ordered pair. So this time I know the y value was 0, and this x value was 8 over 3, and I was able to solve for that. The next question asks if this is increasing or decreasing. This graph is going uphill, which means this is an increasing function. I can see that because it has a positive slope. It's increasing. And the last thing I have to find is my end behavior. My end behavior asks me for this red function on the graph, as I move left on my x-axis, what are my y values doing? And it looks like my y values are getting smaller as I move further to the left. So as x approaches -infinity, y is approaching -infinity. As for my end behavior to the right, as my x values get larger and I follow this graph, my y values are increasing to infinity. So my y values are approaching infinity as x approaches infinity. That's it for our first function, our first graph. Let's go ahead and take a look at question 2. Question 2 again wants us to solve by graphing, but this time we have a system of inequalities. So we're not just going to find one solution. A system of inequalities is either going to have infinite solutions or none. So let's go ahead and see if we can figure out which is happening in this case. Again, both equations are written in slope-intercept form. So for my top function, I can see my intercept is the number 2. That's on the y-axis right here, 2. And my slope is negative 2. So that's negative 2 over an invisible 1. So that's down 2 over 1. So down 2 over 1. I can plot a couple points here and see how my line is moving. Down 2 over 1. So that's going to make this line. But before I connect these points, I have to check my symbol. This is a less than or equal to symbol. The equal to portion tells me that I can connect these points with a solid line. So I'm going to go ahead and do that. And the last thing I'm going to have to do for this function is to shade it. So let's go ahead and shade this function according to this inequality. It says less than or equal to. That tells me all my y values have to be smaller where I shade. So if I start at this point on the y-axis, the y values have to be smaller. And that goes for all of the y values. For the entire shaded portion of the graph, I have to shade everything below this line. So there's my inequality shaded in. Let's go ahead and take a look at my second function. For my second function, my y-intercept is negative 4. That's right here on my graph. And the slope, again, is invisible. It's the number 1 being divided by an invisible 1. So that's up 1 over 1, up 1 over 1. So we can get some points on here, kind of see how this is moving. So this is my graph, but before I connect this line, I'm going to look at my symbol. This is greater than symbol. It doesn't have the equal to sign, which means my line is not actually a solid line. This is an invisible line, which I'm going to represent with a dotted line. So I'm going to connect these points with a dotted line to say this is actually an invisible boundary and not a real physical space. Next up, I'm going to go ahead and shade for this function. This says y has to be greater than this line, so all of my y values have to happen above this line. So I'm going to go ahead and shade everything above this line here. Now what we notice is that we do have an overlapping shaded portion, and I'm going to shade this a third time just to draw attention to it. Everything here has been shaded by both graphs in this area. So when it says choose a solution, I have an infinite number of solutions to choose from. Any ordered pair in this overlapping shaded portion is considered a solution. So I can pick any number. It doesn't really matter as long as it's in this overlapping shaded portion. So the one I chose for my review packet was negative 7, 4. That's negative 7 up 4. It's somewhere over here. That's in the overlapping shaded portion. The only values in this area that I cannot choose are the ones on the green dotted line, because this dotted line is not actually included as one of my solutions. So I can't actually include this y-intercept at negative 4 because that's not an included portion of the line, or anything else that's on this slope of 1. Any other thing in this shaded area of overlap would be an acceptable solution. All right, we're going to go ahead and pick up with the next question in the next video.